Okay.
All right.
All right. So we kind of already started, but we only got to number 2. So.
Oh, awesome. Sorry.
No,
It was my boss texted me right before, right as I was getting on, as I got your message and asked if I could call her real quick.
Oh, gotcha.
All right. So number 2 is number of people randomly selected.
Yeah,
C.
that's what we put.
Number 3. Did you guys get through this whole thing?
No, we got the number. Like we just got to the question.
So individually, did you guys get through the whole thing?
I got about halfway done. Did you?
Yeah, me too. I literally just walked in the door not too long ago from Oregon, so.
Oh, jeez.
I got to 12.
Oh, yeah, me too. And then some of them I'm like, I don't remember how to do this, so. Okay.
So number 3.
Student.
It's an experiment, right?
I got observational. Because they don't have a control group.
True. They're not experimenting. They're just collecting data.
Yeah. And so I put observational because there's no control over the price.
Like you're thinking.
Right.
I'll concur with that.
All right. Do you agree, Wanda?
Look at my.
Wanda, can you hear us?
I can. I had
okay.
2 papers here, so I'm. So what the question was?
We were on number 3.
I put
They're
D.
matched up with the.
They're switched around on the quiz than they were on the homework assignment.
Ah.
So D on the homework assignment would have been exactly. That's what we got. That D is what we put.
Yeah.
An experiment, because if students don't have control over cereals, would be elected for the study.
No.
Or an observation.
An observation.
It doesn't. So it says A. An observational study because the students had no control over the cereals that were selected. Yeah, they changed the answers.
It would be not over the cereals that were selected. It would be over the price of this, right?
All right.
So it's the second one, Wanda, on the computer part, the computer test.
When they invert the numbers and stuff, it confuses me.
Yeah, I just started writing the first sentence of the question and then writing out the answer. It was driving me nuts.
So okay. Number 4. I probably didn't. It's impossible to determine without a full set of data. Is that it lies where the median is? You don't.
Oh yeah, we're here.
Oh.
I was just because I put it would increase, but I don't know. I guess you could just do it.
There's say it's a median, but there's 100 of them, right? There's 100 students.
Oh.
They 90 of them are 21 years old.
Oh, that's true.
You know what I mean? We only see 5 of them. Say 90 of them were 21, and then, or you know?
Yeah, I didn't realize it
We
was
don't-
99. I thought it was just like 1 through 5.
What was there?
Yeah.
Yeah.
Okay, that makes sense.
So I don't know.
No, that
I feel
makes
like-
sense. Yeah.
I'm probably wrong, but
Probably not.
So I had put
Uh,
down, I guessed at it. I put the median increased.
I just got ruled out.
Well,
You guys,
So tell me your
I feel
theory.
like I did this once upon a time. And there's some rule or something. What Brian is saying is that it's not possible to determine because there's actually 100 like people that they're testing, and so we can't really tell, if it would increase or not because we don't have all the info.
doesn't show something.
Yeah,
Because-
it doesn't show us all the data.
Yeah, because I see that there's one slot missing. So it's C.
Yeah.
Yeah.
So
Um,
5.
60.
This one, I wasn't 100% sure if I did it right. I got 155.3.
I got 95%.
What?
Because
I didn't
this is
even-
my this is
Oh,
my
wait,
reasoning.
hold on. Sorry, 95%.
Okay.
I was looking at 6. I was like, wait a second, that number doesn't even fit in this question. Yeah, 95%.
For question
I
5.
was like, wait, I didn't think it was like. Okay.
So would it be, do you put it in as 95 or 0.95? I think 95, right?
Oh, I think
What's the
so
one?
because it's 1 decimal.
So 95.0?
Tell me the equation to that, please.
So there's not an equation. So how you do it is with the 68, 95, 99.7 rule.
Mhm.
With the 68, it's 1 standard deviation. The 95 is 2 standard deviations, and the 99.7 is 3 standard deviations. Your mean of 70, about 50 minutes. How many standard deviations is 50 and 70 when the standard deviation is 10? So there's 2 standard deviations, which would be 95.
Okay, so when you do the mean 70 of 50 minutes, is there a computation or anything, or you just extrapolate it?
No, so it's just kind of like there's not really a formula. What you're saying is so you have 68, 95, 99.7. 68 is 1 standard deviation, and our standard deviation is 10 minutes. And so there's 10 minutes between the average between between the exam, the time of the exam, the difference is about 10 minutes. And so we're given that the normal mean is 70 minutes, but one person takes and say somebody takes an exam in 50 minutes, how many standard deviations is that?
So basically you're taking the difference. You're just saying our mean is 70. It wants to know at 50. So you'd subtract. So there's a difference of 20 minutes. And so how many standard deviations fit into that 20 minutes? 2 standard deviations. So then that tells you that it's 95%. It's 2 standard deviations away from the mean.
Because 1 and 2. Okay, thank you for extrapolating that.
You're a lot better explaining, Brian, than I am.
No, I'm not.
How did I word this? I don't know. Okay.
No, you're good.
So
6. Okay, I got 155.3.
Yeah, I had no idea how to do this, which I felt really bad because I know that we've done this 1,000 times.
I can't remember exactly how to do it. Did you get an answer for this one, Wanda?
No, I put a question by it.
What?
I put a question mark on it.
Oh, okay. So see if you guys think I did this right. I just use the equation to find the z-score and put x minus 150.7, the mean, divided by the standard deviation equals, and then I use the applet and put in 35 and then got a z-score and then put that z-score in and then solve for x. Does that make sense?
Oh.
I don't know if that's the right way to do it. I couldn't quite remember, but that's the way what I came up with.
It sounds better than what I have.
Do you think that's right?
I don't know. I remember something like you put it into the applet, and then you type like 0.35 in the area, and then you shade to the far left because it's less than 50.
Okay, so that's one thing I didn't know exactly was which way to shade. That would change my answer. Because I shaded in the middle. I was like, wait a second, where do I shade? And I wasn't sure, so I just picked the middle. So I think you're right. I remember that too. So you shade to the left because it's 35th. So
it's so frustrating because I know that we did this so many times.
I know. So then our z-score would be 0.385.
0.385.
See, that's why we do group stuff. So let me go into my Desmos calculator here, change that.
Okay.
So what? I wonder what lesson this is. I wish this told us what lesson it was. So we could like.
Got some information from Miss Wanda.
What, Rick? There's Spanish spaghetti on top of the top and there's French bread over there on the counter, and then in the aluminum foil.
Please picking up information for us.
156.7 for 28.
So tell me how you did that.
If my Google Hangouts work, I'll show you on my computer. So I did say if you basically take the z-score equation, right?
Yeah.
Which would be x bar minus x over the standard deviation.
Right. So,
right.
And that gives you negative.
So I basically just put in all the information except for the x bar and solved for the x bar. So the z-score we got, I put that into the equation, and then so it would be x minus 150.7 divided by 10.2 equals negative 0.385.
Okay, I do think that's right. I remember doing something like that. How much you get? Okay, almost. But I remember.
You explained that so well, Brian. Please explain it again.
So we're trying to find actual number, right? We're trying to find an actual the L score. So the equation for z-score is x bar minus over the standard deviation equals our z-score, right?
Yep.
We have a certain amount of information here already. We just don't have the x bar. We have everything else.
Mm-hmm.
So write out the equation. We have x bar minus our mean, which is 150.7, divided by our standard deviation, 10.2, equals our z-score of negative 0.385. And we got the z-score by going into our probability, because we know we're trying to find the 35th percentile.
So that's negative 3.85?
Area for 35th percentile. 5.
Which way do you shade it?
You shade it to the left because we're less than 50%. The 35th percentile is less than 50. So we shade it to the left. And we use our negative 0.385 z-score. And we put that into the equation, and then we solve for the x bar. And we get whatever I said it was, 146.8.
Okay, 142.8.
46.8.
146.8.
Yeah.
So this next question states that the information is already right skewed, right? So no matter what sample size it's going to be right skewed.
Right, because it's not a big enough population to pull it in.
Yeah.
To be normal.
Okay, that's what I thought. So it's right skewed. Okay.
Did you hear that, Wanda?
Right skewed.
Yep. All right. The 8. Oh.
So I had a question on this one. Did any of you guys understand this one?
No, because oh, wait. Oh. I read it wrong. Wait. I am confused. Yes, I am.
I have to find out where it's at.
Asking for...
I feel like this one's worded differently than the...
Oh, it's totally worded different. The other question did not make sense at all.
No, but this one's worded differently. Okay. Because this one makes sense.
Yeah, you just don't.
Please.
It would just be 850. The heck?
Would it be 8550 minus 8544 over the standard deviation?
Yep, that's easy. And then over the standard deviation divided by the square root of the population, or n. Right?
Oh, yes.
The other one stated the mean again. So it would have been 8544 minus 8544.
Yeah, that's what I have like I had like 0 question mark. Like, like I don't know.
All right, that makes
so be
more sense.
Over 12 over the square root of...
So, 855.
Of 20.
20. So 2.236.
Yeah.
And Desmos is awesome.
Yeah, that's what I'm using right now. I really like it.
Because I'm like, oh, I already have this other equation in here. I can just go in and change the number, and then it...
Oh, did you save it from when you did it in the first place?
Yeah, I just keep it up.
Oh, that's really smart.
Yeah. So for the next question, all I have to do is go in and change the population size, and then the X bar value. It gives me the other answer.
Oh.
You got me lost here.
So we're on 8.
On 7, you put the mu over the standard deviation and divided it out, which got the what?
for 7 is right or skewed right.
Skewed right. But on 8, it says, suppose a simple random sample of n tanks is selected and the sample mean capacity is found to be 850 gallons. What is the z-score corresponding to the sample mean?
Yep, so we just need to compute the z-score. So we put the information into our equation.
Compute z-score.
Yeah, which is the same equation we used on the number 6. So it's x bar minus x divided by the standard deviation. But since we're using a greater sample size, n equals 20, so we have to go standard deviation divided by the square root of n. And then that gives us our z-score.
And so our x bar we don't know, so we just put our mean in?
We know our x bar on this one. The other one we didn't know our x bar. This one we do. X bar is our x bar is 8550. So because that's our sample mean. So we do 8550 minus the population mean, or whatever it is 8544.
And then the standard deviation is 12 square root of n.
Yeah, divided by
20.
Yeah, 12 over the square root of 20. Correct. And for 8, we got 2.236.
3.26.
Is that what you got, right?
3.326.
0.23. No, 2.236.
2.236.
Yeah.
Yep. And then for 9, we're doing the same thing, same equation we had before. We just have to change a couple of values. It's wanting to know now with a larger sample size of 50.
So you just put the 50 in the n.
R value.
And the 840.
Is 8540 now rather than 8550. So we're changing our x bar.
So the 85. The
Sample size to 50.
Is our,
then that'll
how do you know that that's our x bar?
So the x bar is always going to be it's the sample mean. So it's always going to be the one they're asking about. It's not going to be in the data that they give you.
Okay.
It's the one they're asking about because it's the sample that's out of that big population.
So it's going to be an understood thing that you should know that.
Well, no. So to like know the rule on it is, so what this question is asking is they have this big population and the population has a mean and a standard deviation, but then they're going to take a little sample out of that population, and then out of that little sample it's giving you the mean, which is it has your mean. How do I word that? It's asking what is the chance that if we pick 50 samples out of this big population that are that the tanks will be greater than 8,540 gallons. And so we know that they're asking about that 8,540 gallons because they're talking about that little sample that they took out of the big population. So that's going to be our x bar.
So it's going to be 8540 minus 8544, 12, and the sample is going to be now 50.
Correct.
Where are we getting the 12 from? That's our standard deviation. Where is that at? Is it in the above?
The standard deviation.
There it is. Okay, it was in the above. It's above in my other screen.
Yeah.
Let me get my calculator out. I'm looking for my calculator. I had it with me at the office. There it is.
Okay.
We're ready to move on to 10.
I got a calculator.
Yeah, so that one you got negative 2.7.
Yeah, but I just realized where it's asking for the probability, so just throw that score into the probability applet, and that's 0.991.
Oh, okay. Is the other one asking for the probability?
No, just the z-score.
Tricky.
I know. The 10.
I put
10 is a probability of a type 1 error.
Yeah. That's what I put too.
So you put Wanda?
Let me see. They're not linked to the ones we got here. I put down the probability of rejecting the ha, whether it's true or not. Or I'm just on the wrong question here.
No,
that's the same question.
Okay.
If you look at the definition of a level of significance,
Mm-hmm.
in the index it says the number that is used to determine if the p-value is small enough to reject the null hypothesis.
Mm-hmm.
Also, the probability of committing a type 1 error. So,
the probability of obtaining a test statistic at least as extreme as the one you calculated, assuming the null hypothesis is true.
True or not. I could kind of see how that one.
I'm in the middle of my Google class here.
I don't know, because the one you selected looks like it would be true as well. I'm just not 100% sure if it is, but I do know for sure that the probability of a type 1 error is true.
because that definition says it.
So the definition is the probability of a type 1 error, or the probability of rejecting the ha, the null.
Yeah.
Whether it's true or
It's the probability of a type 1 error. Is the definition that he read out of the index says that the probability of a type 1 error is the level of significance of a hypothesis test.
Mm-hmm.
Okay, what lesson was that?
It was in the index.
Okay.
It's in the index, but that would be also in lesson. Click on it.
Yes.
That would be lesson 9. Question 11. I never know if I'm
So where do I go down
selecting the right one on
They're kind of
the
the
one
same.
that seems right to me is we're 95% confident being height.
on 5 different times.
Yeah, that's what makes it's a level of competence, right?
I'm on the right side.
That's what I put, but
Yeah.
sometimes I get them wrong and sometimes I get them right. And so then I don't know if one of us and this one are so similar.
Yeah, and it says that there's more than one that are right, so mark all that apply.
Yeah.
Um,
I know it's not the third. It's not the first one. So it's I'm thinking it's just the last one now. Like either
could it be the first one? No, that's not right. It's not the first one.
Because it's
Yeah. I don't. It's either the last one and the second to last one, or just the last
one. I would say
it's
the
the last one.
Yeah, I do too. Wanda, for that one, we got for number 11. It's the very last option.
Okay,
Okay, you guys keep going. I'll be right back.
Okay. Number 12.
I'll call you back when I'm done, okay? Sorry, my son just called, so let me get caught up with you here.
Okay, we're on number 11. Did you get you got number 10, right? Yeah. So at number 11, we just chose the very last option.
I think I did that one too.
Okay.
Because I kind of like ruled it all out of.
Yeah. Okay, and then 12. Marine biologists have been studying the effects of acidification of the oceans on the weights of male beluga whales in the Arctic Ocean. One of the studies involved a random sample of 16 beluga whales. So we have a population of 16. Wait, where did it go? Oh, so for this one, I put, yes, the distribution of sample means is normal because the sample size is large. Because our samples, oh wait, never mind. I put yes because the data that it started off normal. Did you get that one for 12? The distribution, yes, the distribution of sample means is normal because the data is normal.
Okay, back down here. I put no, the distribution sample mean is not normal because the sample size is too small.
But it's not too, well, it is too small, but the, like
because the p-value based on the test statistical, we use the applet. I calculated it somehow.
So this one you don't have to calculate. Or in the,
you just got to look at it.
Yeah, one second. Does it say it? I'll tell you. So it says their data follow a normal distribution. And so then that's how we know our distribution is normal as well.
So it's the second one, right?
Yeah.
Because there's more on a confidence interval, how many sample sizes do you have to have?
So
you normally have to have 30, right? You have to have 30 to be normally distributed, or it has to tell you that it's normally distributed.
Which
if it tells you normally distributed, you don't even have to worry about the size of the sample. It could be 2.
Because they probably did a QQ plot on it.
It's normally distributed, so it is normal.
Okay,
so
thank you.
So this one is 16, which isn't large enough, but
they say it's normal.
Because their data follow a normal distribution, so we know it's the data is all normal. So the requirements are met because it's a normal distribution. It's kind of tricky.
Yeah.
I gotta get something to drink. I'll be right back.
Okay.
So it's the second one. Yes, the distribution of the sample mean is normal because the data are normal.
Yep, that's what I put as well.
Okay. So 13.
Oh, I didn't get to this one, so.
Me neither. I would stop at. I didn't get to 12 either. So
Okay.
we'll just work our way through it. I might have to go here in just a little bit, but
Okay.
I'm gonna get as far as I can. So.
Okay.
Is Wanda here?
No, she went to go get a drink.
Oh, okay. All right. So p-value, this should be easy. You just put the data into an Excel spreadsheet,
Yeah.
and it's one set of data. So we're
Doing a 1.
quantitative.
Okay.
There'll be a one sample t-test. So p-value is 1. Wait a second.
No, I'm still.
What's the? Let me read the rest of the question. So it's less than.
Now, when you look at things, how do you know what if that was, like you said, a one sample t-test based upon what the data is?
Yeah. If you open the data and you say, oh, it's just one, like
one column of information of numbers.
It's a one sample.
Oh, okay, because then you open it. Okay, I see what you're saying.
Yeah.
I'm opening it because I want to be on the same page with you guys here.
Perfect.
What's the value for a null hypothesis, though?
That's kind of what I'm wondering. If we change that though, does it change the p-value at all?
Yeah, that's what I just did. It does.
Let's read it again.
So enough to avoid the pub.
Okay, I see it. So that would go into your one sample t-test. And this is going to be...
So it would be 39. That would be the n.
Yeah.
N is 39.
Oh, I have no idea. Null hypothesis would have to be the S&P 500.
So it's less than the S&P 500.
Yeah. Oh, so it would be not greater than, it would be less than, right?
Yeah, it's less than, but you change the value of the null hypothesis that changes the p-value? So is it 0 then? So it's equal to 0 or
less than 0?
I think it's 0. And then that gives us a relatively normal p-value.
That's all we need. I could see it.
Okay. You guys are probably Excel wizards. I'm not.
Well, it makes it sense that it would be 0 because we're looking for any change or any decrease. I
think that is right.
Okay.
Or maybe somewhat.
Close to
that I expected to have in there. It's not. And I tried to live through, but I had to actually work hard and get my pants back on to come ass.
I'm sorry, honey. I'm in the middle of a test. You want me to go get you a drink now?
Just bottle of Mountain Dew. It's cold. It wouldn't fly.
Okay. My husband's not feeling very well. I need to get him a drink. I'll be right back.
Okay.
I'm sorry, Rick.
So this is dependent.
Yes.
Okay, gotta tell.
So it'd be
The second one?
the second one, yeah. These are long questions. Okay.
I know, and it's like none of them tie together.
Yeah.
It's like each individual question is long.
Jeez. Oh, we've done this data so many times.
Mm-hmm.
These are independent though, right? Or not paired, I guess. Oh, they
are.
They are.
I think, yeah. I think they're paired sample t-tests, right?
Yeah. Because it's the same flight, just different company or something.
I think I remember that because I think I got it wrong one time. I put it as not a paired.
Okay, sorry.
That's okay. You're a busy woman.
My husband's been very sick. We got out of the doctor's office today and he fell twice before he could get to the truck. And it's just, his health is failing. And when you see your companion start getting sick, I really need the Lord's help in this test because I really need to pass this class. So I'm starting a little leggy here.
You're fine.
You're okay.
I'm just really sad. I don't know what to do. I got my p-value for 13 as 0.9999847.
Sorry, what number question is that again?
I'm back on number 13.
So when did you put your data in?
Yeah.
you have all your data in, but for your null hypothesis, it's 0. And then the type of test is less.
My whole null hypothesis is 0, and my confidence score is 0.95.
Yep. And then the type of test is a less than.
And I have greater than. Thank you.
Yeah, that's like the default, yeah.
So my p-value is changed. Thank you. It's a 0. It's nice that when you get the right information in, huh?
Yeah.
245 then.
Mm-hmm.
That's 95, and it says 0.
Have you done every question in the test?
I've done about till where I needed to put my graphs in, and I'm not understanding on how to get some of the p-tests.
Okay. Yeah, because we only got to 12,
I went through the whole quiz.
Okay. Yeah, we only got to 12, so.
Okay, we'll work through them. That's how we learn.
Yep.
So 16 a day.
Confidence level.
And then for this next one, we put it into the applet or into the paired sample t-test. My p-value, I got 0.96.
I have a question on 13. Where on the null hypothesis, how did we get 0?
So you explain it.
We're kind of guessing that a little bit because it doesn't really give us a clear representation of what the null hypothesis is. It doesn't give us a value of what we're comparing it to. Since it's not giving us a value, we're just seeing if there's really any change. So it's either the null hypothesis is equal to 0, and then the alternative hypothesis is not equal to 0. Or it is less than 0. Sorry, less, right? I don't know.
Yeah, it would be less than.
Less than. But we're just not 100% sure on that. But 0 is kind of the only thing that seems like it would make sense to put as a null hypothesis. Because there's no other value to put. So why would you put 125 when there's, you know what I mean? There's nothing to put there. So we're just assuming that it's 0.
Okay.
But, and then 14, we put that it's B. B is in boy. So the second one, because dependent sampling, because you can't pick one husband without picking the other wife. And then 15, we need to opened up the
okay, data. Back on hold on here. Back on 14. I always get confused on these. And I was trying to extrapolate today. You got couples that they're independent of each other, and they want to know about the mean income of both of them. And so is that going to be categorical? It's going to be quantitative because it's numbers, right?
We're talking for 14?
Yeah. Because you have to
we're not trying to determine if it's categorical or quantitative. We're just trying to determine if the data or the sample is the two data points are connected, they're dependent of one another, or they're independent of one another.
So it's going to be a 1 sample or a 2 sample? It doesn't matter. This is a different kind of question.
Different. We're not inputting any data in here. It's just asking basically.
If you know it.
Independent sampling or dependent sampling. And we would use dependent sampling.
Because they're both separate.
With one husband, you have to pick his wife as well, or vice versa. You can't have them independent of one another. They're dependent of each other.
So dependent sampling, he needs to select couples for their sample. So whether its particular wife is included depends on whether her husband is included.
Right.
Because it's a couple. Okay. I have to be able to look at this and discern.
Yeah.
Yeah.
And then it's asking on about direct flights.
What did you get for that p-value, Brian? I deleted the math to my
I got
differences.
0.096.
Okay. I'm just gonna.
And then I need to know how to calculate that, because you have to do a z-score for it and put it in there.
No,
so I didn't know what to put.
That one you just put in your Excel spreadsheet under your paired sample.
Is that what we do?
Yeah. And then it gives you the p-score, unless you want to calculate it. But it makes it easy.
Well, let me go ahead and get there. So this is going to be a paired sample t-test. I have such a hard time moving these things.
Mhm.
L-bio 24. Direct flights. I had that one open already. So where do you put what? Do you put the 14 in the first column?
Yeah. These ones are just how they're set up in the data that they give you.
This question seems so familiar.
Yeah, we've done this one before.
But I didn't know where to look for it.
I knew we'd done it before, but I had no idea what it was about, though. I was like, oh. It all blurs together now.
Yeah, it does.
And so what goes in the C column? Nothing?
It should calculate a difference for you.
Okay.
Did it
So
do it?
Don't get ahead of myself here.
Yeah.
No, C didn't do it.
Oh, it didn't calculate itself?
Mm-mm.
Oh, you must have deleted the equation to make it do that.
Yeah, it's giving me toes up for it's giving me a mean and a standard deviation. It's 0.95 confidence and 0 and not equal to.
And then what did it give you for your p-value?
Let me shrink this so I can see it. I got it too big. There. Maybe I'm in the wrong test. Well, there it is. My p-value is nothing. So my equations aren't in there. I guess I'm going to have
It
to
doesn't
start
have
over.
it.
I'm going to have to start over.
Yeah, you must have it. You must have deleted the equation or something. I can tell you that when it does calculate it, you got it set up right. It would give you the p-value of 0.096. And so that would be 15.
Well, I want to be able to do this because it's going to be on our test. I want to be able to know how to do this. So, and it's going to be in the, maybe I put it in the wrong sheet. Is it a two sample z-test? Or what sheet?
No, oh no, it's the paired sample.
Paired sample, yeah.
Is that what you had it in?
Yeah. Well, maybe not.
Yeah. So sometimes you can accidentally delete the equation that equates the differences for you. And in order to get that, I don't know how to put the equation in. In order to get it back, you can just re-download it.
So that's going to be a paired sample t-test for means.
Mm-hmm.
Right?
Mm-hmm.
Okay. Doing this again. Okay, here we go. 14. And 90 days, right? So I looked at this problem, I thought,
Did I hang up on you?
No, here.
Okay. I don't know how to work this phone.
I don't hear your dog today.
I know, I locked him out.
I locked out my 1-year-old too.
Probably not in the backyard.
You could probably hear him screaming all the way from downstairs.
Oh.
It's still been
He's got a couple of teeth coming in, so he's not a happy camper.
I bet.
I'm doing my paired sample t-test and it's not giving me the information.
Yeah, I'm thinking you're just gonna have to re-download the quantitative inference procedures. Re-download it. But I've got a lot of homework tonight and I have to work in the morning, so I'm...
Hey, I'm just going to have to do this on my own then. Let's move on.
Do you want the answer and then you can check it?
Yeah.
So it is 0.096. And then we use that p-value to determine the next question. And so it's lower than the level of significance. Oh, wait. No, it's higher.
It's greater than.
Yeah, so it's yes. Because the p-value is greater.
I think it's the first one.
0.096. And the level of significance is 0.05.
Oh.
So it's going to be more. more than.
Reject.
Right.
So
Okay.
then that means null is true.
Correct. Okay, yeah.
So
So it's going to be number 2?
I see. No, number 1. Because when you
when the p-value is greater than the level of significance, you fail to reject. It's always insufficient data.
Wait, you fail to reject if it's greater?
Yeah.
So it's greater than. So we
fail to reject because it's always insufficient.
Which is saying that it's equal to.
Okay.
So it's saying, based on the rules, can you say there's a difference? No, there's no difference because it's equal to.
Oh, okay. I see.
Right?
Yeah.
Kind of confusing.
Yeah. At one point I had it down, but
I know.
I lost it. Realistic.
I think that's, I don't know. Right. So yeah, so one, we got the first one for 16.
I'm going to go with you on that, but I put a question mark on the second one. Question 17. A real estate company wants to evaluate 2 of their home appraisers' consistency in preparation for their annual state certification. It's important that different appraisers be given to give similar estimates for homes and other properties. The company selects a random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate of the home value. And after they receive the estimates for each home, the company subtracts the value given by the first appraiser from the value given by the second appraiser. They create a QQ plot of the differences and see that the points in the plot roughly form a straight line. Are the requirements for using the desired confidence interval satisfied? And I put see where my papers are.
I'll put the third one.
I did too.
And I also did.
Perfect.
But I also chose B too, if it correlates with their question. Nope, it doesn't correlate with their question.
Oh. Did you get yes, the distribution of mean differences is normal because the data have been determined to be normal?
Yes.
Perfect.
So 18 now, suppose the company's previous question wants to do a hypothesis test, determine whether their estimates given by the 2 appraisers are different, which are the following. So the first one.
Mm-hmm. Because they're different.
Yep. So it's asking if they're different, and so we have to equal to, and then the second one would be not equal to. 19. Suppose you create a 95% confidence interval for a mean. You've been told before this was saying you're 95% confident the true mean is between Exactly what does this mean? The first one?
But if we do the first one, then the last one we did was wrong. The first one says there's a chance. And there's no way. That's a false.
The first one's false?
Yeah, because there's no... To have a chance, that's not a true statement. It's either going to be here, 95% of all the 95% confidence interval actually contain the true mean. We are 95% confident that the true mean is between this and this.
No, because when it's asking the 95% of all 95%, that's never right. They have this in like every one, but you have to rule that out because that's kind of like a trick question. Yeah, it's not a trick. It's just kind of like a.
Do you know your stuff
That's
or
just
not?
not right, right, Brian? What do you say?
Yeah, that's what I think. So when we're stating a confidence interval, we're stating that the possibility of the tree is between those two numbers.
So that'd be number.
States that the true mean is between those two numbers is the first one.
Mm-hmm.
So all the other ones, like 95% of the data between those 2 points, that's not what it's saying. 95% of all 95% confidence intervals actually contain the true mean. I don't even understand that. That doesn't even, what's 95% of all 95?
Too much. Yeah.
So okay, so look at it this way. So if it's saying, so in the question it states we're 95% confident that the true mean is between that, right?
Uh-huh.
And then, so that previous question,
It was
both of them then?
both. That's what I'm thinking.
Yeah, I think so too.
What number is that?
It's 11.
Okay. Sweet.
That would make sense.
Mm-hmm. So for 19, Wanda, it's A, and it's the A on the computer test, not the homework.
Yeah, I'm trying to look through my questions here. So you're getting 19 as a A?
Yeah.
That word chance is a no. There is no chance. That's a false statement. I'm going to go with number 3. 90% of the data are between this number and this number. Because I know that the word chance, that is not a correct statement. There's no chance about it.
Okay. I'll have to go back and.
So it's either going to be 3 or 4. So I wasn't sure.
Sorry guys, I had to run and grab a piece of pizza.
You're good.
Around 20?
Yeah. I don't.
Do you guys want to do this?
No. Is it just 4 divided by 5?
Well, 4 divided by 5 is our p-value.
And isn't p hat equal to p or something?
Ooh. But we're looking for n.
Just kidding. Oh man. Okay. Let's look back at equations.
Oh, how do you? Wait.
P hat equals x over n.
Wouldn't it just be 30?
P hat equals x over n.
It doesn't matter what the p-value is. If we want it to be normally distributed, it doesn't have to be 30.
Why? Oh, yeah.
What is the smallest value of n?
Right.
So are we, like she said, then how do we extrapolate that? Or are we putting it on that 97, that
I don't know.
Well, because Wanda's saying the equation's p hat equals x over n. Can we, well, I don't know.
Oh, that's right.
So what is the smallest n that satisfies the requirement for a normally distributed p hat? If p is equal to 4 over 5.
What's the equation for p hat again?
P hat equals x over n.
I still don't think we have enough information to solve for it, though.
Mm-mm.
What about in your DESCOM thing?
Oh, is this equation? This is totally where it's like p times n is greater than or equal to 10, and then n times 1 minus p is greater than or equal to 10.
No, that's a confidence interval.
Because there's the equation to determine the value of n, but we would need to know what the percentage is, the 90, 85 or whatever, so we can get our z-score. We need to know the z-score and the margin of error. So it's not that one.
No, there's that equation. Oh, what is it called? It's let me see what it's called. Because it's not the confidence interval. You use it to determine if it's a normally distributed for the p-hats, and it's those two equations.
Yeah, it's NP is greater than or equal to 10, and 1 minus p-hat is what they're greater than or equal to 10.
Yeah. Oh, is that the do you need the margin of error and everything for that?
No, but that's just to determine.
That's a requirements for a confidence interval.
Oh. I thought we did questions like this. Because then you can solve for n using that. Because
yeah, but
I don't know.
Yeah.
Let's move on and come back to it. We'll have the Holy Ghost help us.
Okay, what number?
21.
Okay.
Your little brother has a career batting average of 0.233, and you want to determine the probability that he will have a batting average of over 0.250 next season when he will be up to bat 40 times. Are the conditions met so that the sample proportion of p-hat will be approximately normal?
Oh, so that's the equation I'm talking about now.
What it's asking is the 40 times 0.25 more than 10, so the conditions are satisfied. So it's a dual thing. You have to do both of the batting averages to get your requirements to see if they're met. So that's going to be your X over N to get your p-hat. So you have X, which is your 0.233 over your N of 40 to divide that for your p-hat. And that's going to be your N1. Then your N2 is going to be your...
So it would be the last one, because 40 times 0.233 isn't greater than or equal to 10. It's 9.32. So that requirement fails. Does that make sense?
Hmm. 0.233.
So in this case is p hat equal to p hat?
P hat is equal to x over n. And so your p hat is going to be, to get it, is your x over n. So your first one's going to be your first batting score over your n, which is 40 times. And then your other is your 250 over 40 for your n2. So when there's n1 and n2.
Well, here.
The sample size is n more than 30. The sample size must be normal. That's a yes. But this is not a multiple guess. And then on the 0.233, when you get your p hat, it is less than 10. So I would probably have to concur with what you said, Hannah. It's 0.233 is less than 10. But I think you have to have your requirements met. And do all those formulas.
So you guys think it's the last one?
Yeah, that's right. It's the last one.
Okay.
Yeah.
Okay.
Okay, so 22.
Hey, we're halfway there.
Your test statistic is equal to p hat minus p. And I don't know the second part of it. I didn't write the formula right. So I need you guys to kind of look through what you have for your formula for your test statistic. Because on you get your z-score by doing the p hat minus p, and is it standard deviation by it? And then over square root of p standard deviation, brackets 1 minus p over, it's either a 0 or standard deviation over n. So it's a hairy equation. Unless you can stick this into a Excel flow sheet and get it.
This one, so 22 is just asking to explain the data.
Oh, see, I'm off base with they're not matching again. So when you put your p hat, which of the following is the most correct interpretation? If I got my applet still open here. Normal applet, here we go. Oops, this one. Bummer, dude. He didn't move over.
Oh, so this is like the same. that 19 is asking.
Mm-hmm.
Just with the different, like with
Yeah, I'm just trying to remember what exactly he had itself.
That's what I have it written down, like the definition, I guess. Let me. P hat equals X over N. And it means
so it's saying for this sample size.
Sample size is 140. And
yeah, it's the last one.
I'm gonna read it. Geneticist takes a sample random N140 gamete sex cells from the testes of a dog to determine the proportion which contains the chromosomes for development into a male. Assume the unknown true proportion of the dog's gametes that contain the male chromosomes is 0.46%. Dexter survey and calculates the P as 0.512, which of the following is the most correct interpretation of this statistic? So it's wanting chromosomes to turn into a male, or development into a male. It's not it's saying that the dog is determined the proportion which will contain the chromosomes for development into a male. So it's all the gametes in the dog's testes have the male chromosome. So the question is it of the gametes or all the gametes?
It's of the gametes in the sample. 51% of the gametes in the sample have the male chromosome.
You have to really twist it into these. I remember doing
I'm
this.
gonna have to do it, guys. Sorry,
What, Brian?
You guys hear me?
Yeah.
I didn't hear what you said.
What? I have like all my extended family downstairs. They've been waiting for me. They're doing a Christmas thing, but
okay. Do you want to go now or?
Want to work on a few more?
hello? Are you guys there? Hello?
Yeah, can you hear us?
Oh, there you go.
Do you need to go now or?
Yeah, just here. Let's get through a couple more questions and then.
Okay.
Yeah.
So for 22, it's the last one, and then 23. Would this one just be 320 to 750?
be
X over N, right?
Yeah. Yeah.
So just be 0.427. Is
Yep.
what I get. So for that one, Wanda, it's super simple. It's just asking the P, which P equals X over N. So then you just do 320 divided by 750.
So do you divide 320 into 750?
Yep.
Because the X is 320 and the N is, the 750 is the N, which is the sample size.
Yep.
N is 0.247.
Yep.
So the next one's easy. It's 0.091.
Yeah.
How did you get that?
Because it tells you the area to the right under the standard normal density curve is 0.091, and we know that under the standard normal density curve is the p-value.
So right under the standard normal density curve is the p-value.
Yep.
And then the next one
So that one is greater
is
than
the last one. Is known the distribution of fertility levels of Cocker Spaniels is normal.
Oh yeah.
But this normal doesn't matter on the value of N, right?
Right.
So any N will do?
Yep.
Hypothesis test, huh? What is the correct alternative hypothesis test for this?
Swish! Come on.
No, we're on 26.
Yeah. Yes, because we know the populations are normally distributed, right?
Because of the sample size.
Yeah, because the sample.
Well, are they? Yeah, because the sample size is big enough.
Yeah, I think so. Yeah, because it's just an independent sample t-test.
And none of the other ones would be right because correct.
That's an Hanover test, isn't it?
Yeah, and then the 2 and 4, like you can't determine one without the other. So they would have to be both.
Yeah. So it's the third
one. So 27.
Are we doing P or are we doing a standard deviation? Because they have P1 is not equal to P2, or your mu 1, or your mu. So what test are we using?
Well, it's a paired sample test, so it would be the second one, right? Or the third. The third.
Yeah, it's the second one.
Oh, because it's the difference.
This is the difference. We're trying to find the difference, yeah.
Because it's before and after, so a U1 is not equal to a U2.
No, it's the second one because the D and the U of D is difference, and so it shouldn't equal 0 if you're wanting a difference. Because that would be for independent, right? The U1 and
Yeah.
Is that what the D means?
Difference, yeah. Right, or dependent, I don't know.
I think so. I think that's right.
Weight Watchers wanted to predict how much weight the client would lose.
Oh, what does residual mean?
Say, what good is my homework if it don't match with the questions, right?
Yeah.
But I chose a question mark on B. His actual, there it is in our question 28. It does match it. His actual weight loss was 5.5 higher than his predicted weight loss. I put a question mark because it's not predicted A, it's not predicted D. So it's either going to be B or C. His actual weight was like weight loss was 5.5 higher than if he would have been if he didn't exercise, or his actual weight loss was 5.5 higher than his predicted weight loss. Well, he did exercise, so that's why I chose B.
I agree with that.
Yeah.
You have to really look to see what it says on those answers and kind of deduct them. 29, for the study in the previous question, the B1 of the regression line was 5 pounds. Interpret the statistic.
Do you need to go, Brian?
Yeah.
Okay.
Sorry, my whole family's waiting on me.
You're good. Thank you for staying so long.
All right.
Have a nice time with your family, Brian.
All right, you guys have a wonderful night. I'm probably going to be up till midnight finishing this and doing other homework and work stuff. But you guys have a great night.
You too.
And we're meeting. When are we meeting?
I think this is our last meeting.
We just have the final project, right?
Yeah. So I guess we probably should meet to do the PowerPoint or something.
So
we have to do the PowerPoint, and she suggested a PowerPoint Google.
Yeah, PowerPoint over Google. Okay.
You guys are awesome. Have a good one.
Okay, thanks. You too.
Have a blessed holiday.
Okay. And I have to be done at 8 so that I can get the rest of my assignments done. But I'm in 6 classes, so.
Wow.
Killing me. I'm busy.
Okay, let's kind of blow through these then.
Okay, for the study and are you on 29 too? We're on 29, right?
I'm on 29 too.
Okay. For the study in the previous question, the B1 of the regression line was 5 pounds. Interpret the statistic.
Well, B1 is the slope. So we need the definition of what is the regression line is between, what is the regression line?
So for line regression equation, slope equals as x increases by 1, y increases or decreases on average based on the estimated value of the slope. So it would be the third one.
What lesson was that? That was just our previous one, wasn't it? 23?
Yeah.
So the regression line is
So as X increases by 1, Y increases or decreases on average. So third one, because it follows that exact definition. Just inserting the data, basically.
Roger that.
Okay, number 30. When creating a scatter plot, a residuals plot, and a QQ plot, which of the 5 assumptions about linear regression are being checked? Check all that apply. Oh, geez. Okay.
That wasn't our last test, wasn't it?
I don't know.
Because it was the X values are measured
test,
without error. The residuals are normally distributed. And the observations are, there's one more, but I couldn't remember if it was the observation, are the observations,
Oh, never mind. No, which of the 5? Oh, there is a linear relationship between X and Y.
Are the observations independent?
I don't know. Wait, I wrote this down. 1 second.
What, right? Yeah, you need to get some sleep, Rick. You're on sleep debt. Well, especially with you falling down twice, that's probably going to wipe out your energy level. That's good.
They were just too strange.
Is it okay?
Like someone had decided I was a female.
I know there's more than one answer to this, so
I know for sure it's when you said the residuals normally distributed, and then the linear, there is a linear relationship between X and Y. Do you think it's just 2? Because
I think the observations are independent, but I'm going to have to relook at that. And the variance of an error term is constant for all values of X. I'm not sure about that. And the X values are measured without error. I don't think that it's that one, but I do think it's
you say the
2, 3, and 4, definitely.
Okay. Let's go with that, and then because you picked nice, so. Okay, number 31. I was thinking data again. Okay. Pressures of supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If a seat on a flight does not sell well, an airline may discount the tickets or even cancel the flight. Idaho student wanted to predict the price of tickets 14 days before flight based on the price of the tickets listed 90 days before the same flight. For her study, she compared the prices of one-way flights from London's Heathrow Airport to various destinations in Europe using Travelocity.com. She recorded the lowest published fares for 90 nonstop midweek flights 90 days in advance, and then found the lowest published price for the same destination, again 14 days in advance. The prices are given in the file. Notice that some of the destinations' flights are not available. 31. Compute the sample correlation coefficient of the price of tickets 14 days before compared with the price of 90 days before. So
is this going to be a two sample test?
I don't know.
14 and 90 days?
Well, what's the correlation coefficient? Oh, no, I think it would be, 1 second. Oh, no, it is, oh, let me find it. Oh, it's linear regression. Oh, it's the X and Y for linear regression.
In the linear regression?
Uh-huh. And this is the one where you have to reverse the data. So the 90 days goes first, and then I'll do it.
Okay, so let's get at this other chart up here. It's return. And 14 days.
Yeah. Okay, I got it.
How did you know it was in the linear regression? I mean, you just knew it?
No, I knew it because when it says correlation coefficient in 31, I just remember that was a recent lesson, and then I looked at my notes and and then I remember correlation coefficient, when you see that, that's a linear regression thing.
I just bumped myself out of my test.
Oh no. Good thing it saves it.
That sucks. Too many screens open.
It's hard, yeah. We did a little photo shoot with my dog today because we're crazy people. And
for Christmas?
No,
Christmas?
we live next to a farm. We live in this really, really tiny little town. And right now, like the farm, like the crops have frosted over the top of them. And so they're really pretty. And so our dog is red, so he's like running through it. And we just got new phones that have better cameras, so we were kind of just having fun with them.
I can't get my
Can't get what?
I have this, I'm trying to erase the previous data and it won't let me.
Oh, did you enable editing at the top?
Maybe I didn't.
If you do that, it should let you maybe. Maybe that's the issue.
So Father God, please help me. I always try to make sure I have everything wiped out, because sometimes you put formulas in or data in and you got data below it. This sucks.
Is it not working?
It's saying there's a problem with this formula. I'm not trying to type a formula in. I'm trying to delete the column.
Are you are you highlighting it all and then right click clear contents?
I just click delete.
Oh, this has done this before to me, and you can't even X out of it, can you?
No. How do you fix it?
I don't remember how I did. It did it to me, and I could not get it fixed. And it took me a while just retrying. So try clicking at the data, and then so don't double click or anything. Just go to the number, the very top left number in the data, click and hold, and then drag and cover all of your data in blue.
I did it finally. I just hit escape and went back in. Boy, that.
Oh, did it? That did that to me one time, and I could not get out of it. It drove me mad. Like, I was so mad. But so did it enter it for you, or are you still?
It's click. I'm just saving it for now, so if it does it again, I don't have the same issue. And I'm just saving a blank file with it deleted. And I'm getting back into my course. Well, at least we're down to 31 here. So
yeah, we're making progress.
We'll get this done so you can be on your way.
Hopefully the end is what we just did, so.
There it says quiz and continue quiz. And we are down to question 31, right?
Yeah.
This is kind of like, some of these questions have like 4 or 3 links to them.
Yeah. Yeah, they're difficult.
Now, how do you know which one to put where? Is always the 14 going to be the X? How do you know?
So this one, so the dependent always goes to Y. We know that. I don't know. I don't know.
You just take a guess?
I've just been kind of doing it backwards, because every time that we've done one, it's ended up just being backwards from the way it's laid out. But I don't know that that's right. I just
So is 14 going to be the mean, or is 90 days going to be the mean? Which did you put in?
1 second, let me look. 14 is, I put 14.
Explanatory is X, and then Y is response variable.
Mm-hmm. And this one, I actually did it because first she did the 90, and then based off her 90, she did the 14. So the 14 is the dependent, so I put that in the Y. That's why.
Thank you. I just needed to see your insight into that because I don't see things.
Yeah, I was like, I remember that when I was doing it, I thought there's a reason why I'm doing this, and then I couldn't remember why I did it. I am feeling a new job and end of the semester for sure. My brain is overloaded.
And then our Y is going to be our 14.
Mm-hmm. Yeah.
Okay, here we go. Okay, I finally got it pasted in.
So for the correlation coefficient, that is R. And so under model,
Under what?
R box, and underneath you get 0.780.
For this, under the unstandardized coefficients?
No, right above that.
Is the, it has R and then R squared above it.
So just R.
So R would be the coefficient?
Uh-huh. It's the correlation coefficient. And so did you get 0.780?
I got 0.609.
Well, you got what?
0.609 is my R squared. Hold on here.
Yeah, so the one next.
That's squared. R is 0.780.
Yep, that's what I got too. So that's your answer. I can't work my own phone.
You got a smartphone.
Sorry, I don't even know how to work. Oh, my mother-in-law's calling me.
Oh.
So are you ready for 32?
Hold on here. I'm trying to get this. Yeah, I got to put my scatter plot in. It shouldn't just be in there.
Yeah, if you scroll down, it'll be there.
There it is. It's kind of linear. Sort of, kind of.
I would say with the, so it's positive. And I'd say fairly strong positive association, wouldn't you? Like it's not strong, but it's almost strong.
It's almost.
Because it's kind of scattered apart, but it's not like a straight line.
You can make a line through it.
Yeah, so I would say it's like fairly strong, but not all the way strong yet. Because a strong one is like super tight, straight line.
So whenever they say compute the sample correlation coefficient, it's a linear regression Excel flow sheet. Okay. And I would say that it looks like a strong positive. A fairly strong positive.
Yeah, that's what I said too.
It's good when you can get the right answers. Otherwise, you're going to be guessing if you don't know how to do this. Now for the next two questions. Compute the y-intercept and the slope of the linear regression line used to predict the price of tickets for 14 days before a flight based on the tickets less than 90 days before the same flight.
Oh.
How do you?
Oh, so that's easy because that's in our Excel sheet, and so it says in the unstandardized coefficients, the y-intercept is 115.640. I love when you can just plug it in and get the answer and not have to do the math.
Unstandardized.
Yeah, so it has like y-intercept and slope.
So the y-intercept is 115.640.
Yep.
And then what is the slope? The slope is 0.627.
Mm-hmm.
Predict the price of tickets listed 14 days before a flight on the same flight, costing $2,000. There's a comma of $2,200 90 days flight before. Give your answer. Does that mean we have to invert it somehow, or is there how do you extrapolate that?
So there's an equation. And the equation, I'm going to write it and show you. Let me write it. Let me copy it really quick. Sorry, I'm going to. Okay, so here, if you look at the camera. Ooh, 1 second, sorry.
Y equals BO plus B1 times X.
So BO is the y-intercept that we just inserted 2 questions ago. And then this is the one we inserted 1 question ago. And X is going to be the 200 that they just gave us in the question.
Oh.
That make sense?
It makes good sense. Thank you for sharing that. So the BO is 115.640 plus the Y 0.627. And is it times then? 200?
Yep.
Okay. 5640 plus 0.627. I got 241.04.
Yep, that's what I got too.
Now for the next three questions. It wants our confidence interval for the lower bound. And that is, now when they say the confidence level, is that meaning the slope, the BO, the B1, the slope, or the YBO for the confidence interval? I just get confused on extrapolating these things.
Let me see.
Because if you go with the slope B1, there's two confidence intervals here in our chart.
Oh, yeah, you always go with the bottom one, the slope.
Okay. I needed to know what took precedence. So that's 0.518.
Uh-huh. I don't know why, but that's just what the teacher said in the
PowerPoint. Determine the margin of error for 95%. The margin of error is when you take the confidence interval. I asked the TA this.
Okay.
And he emailed me back. You take the confidence interval, 0. Let me just write this down too while I'm at it. The 0.518, and you subtract it from the 0.735, but you invert it, so it's the positive. And then you divide it by 2, and that is your mean. Or margin of error. Isn't that a trick?
Wait, so say it again.
You're going to take your 0.735 minus 0.518, and then you're going to divide it by 2. And that is your margin of error.
Really?
Yes. Sweet. And I was thinking about some hairy formula.
Yeah. Let me put it in real quick.
I guess I should forward that email to you because you were going to ask him, remember? Or TA?
Yeah.
About the previous question that had that.
And I forgot, so I'm glad you did it.
And I'll have to forward it on to Brian too.
Yeah. Yeah.
Because I got up like in the middle of the night thinking about that problem, you know. And so I texted him, I emailed them through the BYU. I says, I'm just overcome with knowing how to do this. Because he was saying he was all busy this week too with his finals.
Oh, I'm sure, yeah. So 0.109?
For our margin of error is going to be 0.476.
So you do 0.735 minus
518 divided by 2. Did I divide it wrong? Let me look.
I don't know, maybe I did.
0.735 minus 0.518 divided by 2. Let's just do this. 0.518 minus 0.735 minus 0.518 over 2. Oh, wow, I got a different answer.
Did you get 1.109?
Yeah, I did. Thank you for rechecking me on that. I computed it, did something with my calculator, tweaked it.
It's always so scary because I'm like, how many times do I do that on a test? Okay.
Just rounding it up. Yeah.
Okay, so for this one, oh, which one is it?
0.1.
Well,
For the next 4 questions, conduct a hypothesis test to determine if the slope of the true linear regression line is not equal to 0. Choose the correct null and alternative hypothesis for this analysis.
Okay, so it is, I'm looking it up in the textbook, and the textbook says that it is 4th one down. Yeah, because it's like, I knew it was one of these. It's always going to be this. Oh, so it's the last one, not the 4th one. No, the 4th one. It says the last one.
Because it's talking about the beta or the slope.
Yeah, so for these type, additive are always going to be this, I don't know how to say that, b of 1 equals 0.
Beta 1 equals 0, and
yeah.
The ha is beta 1 does not equal the 0.
Yeah, the very last one, the capital B. So that will always be that.
What is the value of the test statistic? Oh, is that talking about this test that we did?
And it's the slope. So where you found the confidence interval in that same like little block.
It's going to be 11.5.
You go a little bit to the left. Yeah. Oh, so close. Okay.
And then
p-value.
The p-value is going to be 4.246.
No.
Is that not what we take for the p-value for this?
Well, because when it has that e,
that means eternal. Or
it means times 10 to the negative 19. So 19 zeros are before the decimal.
So it's going to be 4?
No, I think it'll be 0. But I don't know.
You can't put that one down because you can't because it's exponents.
Yeah. But on the last quiz, we put 0, didn't we?
I don't remember.
Right answer.
And did you get it right?
Uh-huh.
Okay.
Okay, so 42.
What decision do you base on the p-value and the level of significance? And what do you conclude? Well, our p-value is 0.
So we reject the null because it's smaller than, right? I got it confused in my head. If it's smaller than you reject?
If it's smaller than the significance, we reject because we have sufficient evidence.
Okay, so it'd be C. So 43.
Now,
In the United States. Oh.
Go for it.
In the United States, mothers who live in poverty generally have babies with lower birth weight than those who do not live in poverty. The mean birth weight for babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study to test the effectiveness of a new prenatal care program in reducing the number of low birth weight babies born. For the study, 30 mothers, all whom live in poverty, participate in the program, and the birth weight data is recorded. This test would be appropriate for this study. It would be it would just be a one sample t-test, right?
And why would it be a one sample t-test?
Because it's saying for the study, there's only 30 mothers, all who live in poverty. So that's the only the only side that they're doing participate in the program, and the data is recorded. So it's not giving any.
Because a z-test means you don't know what the n is.
Yeah.
And then one sample is you do know.
Okay, so it would be Z, not T. Right?
For the study, they have 30 mothers.
So, yeah, and so it's only one sample because it's 30 mothers and all they live in poverty. So there's no like variation in the data where you'd need two lists of data sets.
Only mothers.
So it'd be one sample Z-test.
But isn't it, Z means it has a known mean.
So
and one,
I don't know.
The t-test mean it has the known mean.
Z is the known one and T is the unknown.
I think so. I'm going with the one sample t-test, but I have to look up the definition again. One has known and one has unknown.
What's the very first thing we learned about? It was a Z-test that we learned about first, right?
I have to go back and look.
I'm thinking, yeah, it's t-test.
That's what your first gut said, and I concur. But I would have to go back and investigate to see, is it the T or the Z? There's a reason why we do. I think the Z was because we had an unknown.
Yeah.
Correct?
Okay. We're almost there. 44. Engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of the vapor pressure of the gasoline made by the refinery is 0.03 per square inch. Which hypothesis test would be appropriate for this task? All right, I've copied this chart down, and I'm going to just...
The statistical test chart? What's quantitative and what's categorical? I think that's helpful.
Yeah, I copied it down because that's what we're needing right now. So, all right, if you know the standard deviation, then it's a one sample Z-test. So this is a one sample Z-test. And then we're right about the t-test.
So on the Z-test, if you know the what?
So if you know the standard deviation, it's a Z-test.
Okay.
If you don't know the standard deviation, it's a t-test.
If you do know it.
No, if it's unknown, if standard deviation is not known, it's a T, as in Tom.
If you don't. So on our last question, is that going to be a Z test?
No, it'll be T as in Tom.
Because we know what the standard deviation is?
Yeah. No. We don't know what the standard deviation is. So sorry. In 43, it doesn't tell us what the standard deviation is. So then it's unknown. So it's T as in Tom. So just remember, Tom doesn't know the standard deviation. And it's a t-test because T stands for Tom. I don't know if that helps, but
it might. Tom doesn't know standard deviation.
And Zelda knows the standard deviation. This point. Okay. So 45. Oh wait, I just changed my answer on accident. Okay. 45. Yeah, an attorney wants to know percentage of Walmart employees in Nevada who are 45 years or older is more than 30%. Which would be most appropriate in this situation? So that would be a categorical test, right? Well, no.
I put down an ANOVA. I guessed it. I don't know.
Well, I don't know. An attorney wants to know the percentage of Walmart employees.
Because ANOVA has more than one set of information.
It would be categorical because we're using a percent, and it would be a 1 proportion. So it'd be a test of 1 proportion. Because it's categorical, because it's a percentage.
Because it's numbers. It's numbers. No, categorical is values that are names and labels. Quantitative is numbers.
And I think I want to say age, though, is a label. When in the reading. And when they use 30%, you know that's a categorical thing. They don't use that in quantitative.
Names and labels. Numbers are quantitative.
But
I think it's a quantitative. Because it's numbers. They're doing numbers.
I want to say, like, they say that, maybe. Quantitative is naturally measured as a number for which meaningful is. Oh, you're right. So age is quantitative.
The question was under quantitative, is it 1 sample or 2 samples?
So it would have to be a 1 sample z-test.
And is the standard deviation known or unknown?
It's no, so it's a t-test. Because it's unknown.
No, that's not what I have here. It says t-test is known and z-test is unknown.
I have it opposite.
And it's got 1 set of data for, in each of those.
I have that standard deviation is, when it's known, is a Z as in Zelda test.
I don't have that. We better Google this.
Yeah, let me make sure.
But I like your little acronyms, though. Okay, here.
Okay, so no, I Googled it and it's unknown is a t-test. So it has to be.
That's what the Google says?
Uh-huh.
Then I got this inverted then. I have the z-test being unknown.
I don't. When I Google it, that.
So I need to invert those, or I have to look it up myself. So 44, we're going with one sample z-test because it is unknown.
44, one sample z. Yep. Oh, wait. No, but it's known. We know it because it gives it right. The standard deviation is 0.03.
So it's going to be a t-test then.
Z.
Known.
So 46.
I have 45. It is a categorical or quantitative.
So you were right. It was quantitative. So I was thinking it had to be one sample t-test. Or is it independent? That's two samples. There's only one sample, so it has to be a t-test.
Because it's unknown? Standard deviation?
Yeah. Yeah.
Okay.
And then 46. A marriage counsel conducted a study categorizing each of the couples as communicative or non-communicative. Among other things, the counselor wanted to see whether the percentage of communicative adult couples whose marriage ended in separation or divorce was the same as the percentage of non-communicative couples whose marriage ended in separation or divorce. Which hypothesis test would be appropriate for this study? So that's for sure categorical. And it's two proportions, or two samples, and I think it's two proportions. We attest two proportions.
Trying to find my papers because I did all these when I was sitting at the doctor's office with my husband. There it is. Okay. 38, 39. Okay, so let's kind of dissect this out. It's a study of couples. Categorizing as communicative and non-communicative. And they want to see whether the percent of they end up in marriage or divorce, are they non-communicative or communicative? So are these kind of like an independent, or it's a paired t-test, isn't it?
No, because t-test and z-test are only quantitative. And this is a categorical for sure. Because there's no numbers involved. It's just kind of what type of relationship do they have. So then when it's categorical, it's either a one proportion or a two proportion or a test of independence. And so we know that it's a test of two proportions because there's two samples.
But they're not really telling us any numbers.
Nope, so it's categorical. Well, they're not telling us any numbers, but when you read it, it tells you that they're doing
names,
two sets of couples, ones that are communicative and ones that are non-communicative.
Labels.
So that's two. Yeah.
A two sample.
Mm-hmm.
A two sample being because it's a couple?
What? Sorry, say it again.
It's deemed two sample because it's a study of couples?
No, it's deemed two samples because it's it's giving couples that are communicative and as a sample, and then another sample is couples who are non-communicative.
Okay.
And then the final one, a business marketing firm specializes in radio advertising. They hope to show there is a linear relationship between the sales and the amount of money a client invests in radio advertising. Which procedure would be most appropriate for addressing this question? It would be linear regression.
Sorry, McKenna. 47 is that what we're on? And we chose for 46 a paired?
No,
a test. Two proportions? Test of two proportions? Okay. Because that is a categorical.
Uh-huh.
Okay.
So then 47 was linear regression. That's easy because it says the word linear relationship, and then you know it's going to be linear regression.
Yeah, that was like a giveaway, wasn't it?
Yeah, I was like, okay. All right, I'm going to go submit it now.
No, we have one that we didn't do.
Oh, I did that one and I got 50 on it. Let me see if it's right real quick. Oh, man. All right. What the heck?
I didn't answer 22. I didn't stick my answer in there.
Do you want me to tell you what it is?
Yeah.
It's the last one.
In 50, and question 20?
Oh, 20? Mm-hmm. So I got 50 and it was right.
But how did you get it?
So I put it into that equation that I was telling Brian about. So if you equation n 1 minus p.
Hold on here.
And n is
what was the equation?
It's the n times 1 minus p is greater than or equal to 10.
Mm-hmm.
Plugged in, n is 40. So the equation.
And p is what?
I plugged in, because you're looking for n, so you leave n blank. Times p, which is 4, or times 1 minus p, which they give you is 4/5, is greater than or equal to 10, and then you solve that out. And then you get 50.
And then you get n, huh?
Yep.
I have to do this right fast.
I've really got to go. I have so much to do tonight.
What did you say was the last one?
What's the answer to 20?
Yeah, the answer to the last one was 20, or linear regression.
Yeah, the very last answer was linear regression. Yeah.
Okay, did you do okay?
Wait, sorry. Yeah, I got an 84. Not bad.
Okay.
If I get that on a
I
test,
didn't
I'll be very happy.
What did, I didn't get one answer plugged in here. Hold on for just a second. Let me go up here. I didn't do 26. What was it?
Wait, what?
Question 26. I didn't have it filled in.
I got out of the test already. What's the question?
A study is planned to compare the proportion of men who dislike anchovies with the proportion of men who dislike anchovies. The study seeks to determine if the proportions of men and women who dislike anchovies are different. A sample of 41 men was taken after the p-hat estimate of the true proportion of men who dislike anchovies was determined to be 0.67. A sample of 56 women was also taken, and the p-hat estimated with the true proportion of women who dislike anchovies was determined to be 0.84. Specified to perform this hypothesis test. Why?
Oh, it was no, because n times 1 minus p was not great. It was less than 10.
Okay, thank you.
Uh-huh.
Good luck on your test.
Really
and where will we? Huh? When shall we meet again for our power data?
I haven't even looked at it, so
we'll just
I'll see. I'm super busy tomorrow, so I work all day and I have to drive up to Rexburg for a bridal shower. So, I guess my only free day is Friday or Saturday. Oh.